Hello and welcome to Andy and Ian Talk Networking. I am Andy.
And I'm Ian.
Hello and welcome everybody. So today we are going to expand on some of our previous sessions where we talked about network observability and kind of networking components. And today, Ian, I want to jump into kind of a confusing subject for a lot of people. They have different views about this. So really, I want to focus on tap-agg versus packet broker. So, in the realms of network
A nice
observability,
and easy
yeah,
one, Andy. A
nice easy
nice and
one here
easy
for just
one.
to kick
Come
us off on
on.
a Monday afternoon.
That
Yes,
sounds
so really,
great.
it's just kind of people when they start talking about network observability, they're putting together all the kind of kit that they need to be able to see what's going on, and I think it confuses a lot of people when they're presented with a product that is a tap-agg and a different product that maybe is more expensive that is a packet broker. And I
Right.
think it really helps people to understand really what the difference is between the two products, where you would select one and maybe use the other one, and kind of how you could architect your network to use kind of both of them to solve the problem. So let's start off with just kind of like the very simple, what is the plain difference between a tap-agg and a packet broker?
Well, I think the simplest difference is features, right? I
Okay.
think that's probably what the customer would most see if you're looking at a data sheet from a vendor, cPacket, any vendor, you would see a difference in the features. Likely many less features in a tap, what would be classed as a tap-agg system. You probably see slightly more ports, you would see slightly less features,
Hmm.
and that would be one concept. So if I then go to the packet broker side, I'm then seeing more what would be generally referred to as a kind of an advanced feature set, or more features, more things going on in that device type. So yeah, that effectively is the probably the biggest kind of difference between kind of a tap-agg device and a packet brokering device.
Okay, all right. So, I mean, one of the ways I also look at tap-aggs and packet brokers is I look at a tap-agg really as kind of like a reference design for a lot of the silicon vendors that produce switches. You could almost take an off-the-shelf switch, put some extra firmware in it, and that is effectively what a tap-agg is. It's nothing really overly super special. It's not like it's got and we're going to cover different architectures of packet brokers and things in a future discussion, but to me a lot of tap-aggs almost are standard off the shelf products from a lot of the silicon vendors, whereas packet brokers you tend to invest a lot more in the development of the architecture, give it a bit more oomph, to give it to be able to do a lot more kind of functionality as you talked about.
I think you're absolutely right, Andy. And as I say, as a guy like myself who came from a switching background, that's pretty much how it rolls itself out. So the point is, yes, that's pretty much correct. You're likely to have a much more off-the-shelf product in the first case, the tap-agg case, and
Hmm.
then in the packet brokering case, as you say, you're likely to have added some other components to give it that oomph, whether it be special processors,
Yeah.
FPGAs, other types of capabilities. And you see that all across the vendors. We're not
Hmm.
just talking about
Okay.
cPacket.
So when you
So
talk
yeah, that's
about
it.
features and kind of the differences between the two, I mean, so what I mean, if we take ports, number of ports, you said a little bit about tap-aggs maybe have more ports, maybe they're higher speed ports rather than your packet broker. Is there an architecture or a way that we deploy one or the other, or do they actually work quite well together?
No, it's pretty straightforward. I mean, I would have suggested that most customers who come to me or
Hmm.
us in this case, are looking for tap-agg to have more broad distribution across their infrastructure, and then they're bringing kind of effectively forwarding those packets, maybe in
Hmm.
basic filtering, possibly
Okay.
at the edge, maybe highlighting particular streams, etc., and they are sent
Time
to
stamping as
a
well, maybe.
possibly
Yeah.
timestamping, though that's not a given
Hmm.
on tap-aggs. If you're looking for timestamping, make sure you check the small print, so to speak.
Yeah.
Very important. But yeah, you could have timestamping there potentially, and then it will be sent on to a more advanced packet brokering system for a little bit more work, deduplication as an example, things
Okay.
like that. I'm doing that probably further back in the infrastructure. So there's probably things like that are probably the key opportunities there. But certainly, things like adding VLAN tags,
Hmm.
the ability to, when you're kind of saying, well, this came from port one, port two, port three, port four, you can use VLAN tags for that. That's something that makes a lot of sense. And doing that at the edge, and then as they get fed back into
Right.
the system, the packet broker says, "Well, thank you. This came from VLAN
So I know
5.
exactly where it came
Therefore, I
through.
know
Yeah.
exactly came from." And when you send it onto your tools or you
Hmm.
send it onto a capture system, you really know exactly where that particular packet stream is coming from. So it's pretty clear how that should all come together, I think.
Okay. Yeah, so the advantage then really is that the packet broker takes you kind of to the next level down inside the packet. So the tap-agg, if you like, is kind of doing a lot of the header manipulation is probably one way of looking at it. It can do things at a VLAN or a MAC layer, maybe even an
Yep.
IP layer, but it can't really dig down deep into kind of a lot of what's going on inside those packets,
We don't really
which
probably want you don't probably want it to, right? That's the key
yeah,
thing, right?
yeah,
You're
because
trying
you've
to
got so many ports, you've got,
yeah,
maybe
yeah.
400 gig ports coming in and things like that. Yeah, or
Yeah,
even
you want to
even
move
higher.
the packets as quickly as you can
Hmm.
through into the tools because that's the whole premise, that's the whole point, that's why you've installed any type of packet monitoring infrastructure. Uh, that's the idea is you want to get the packets from the network into those tools as quickly as possibly for that network observability analysis.
Okay, yeah, sounds good. So it sounds really then that, like you said, you've got a really nice kind of break where you'd want to use the tap-agg right on the edge with a higher speed, to get that data, aggregate it, and forward it out to where it needs to be processed. But actually, when you want to start doing real manipulation and in-depth packet inspection and DPI and maybe things like MACsec or various other protocol kind of inspections, that's really when you need the packet broker because the packet broker has that different architecture, has that ability to really kind of dig in deep to what's going on within kind of every single packet at the line rate, which obviously the tap-aggs can't. 48 ports at 400 gig. I mean, the processor needed for that would, it would be able to heat your house water. So it's just,
That's
it's
exactly
really
right.
just not practical for a lot of, for multiple hundreds of ports at the edge.
Yeah, I think that sums it up very nicely, Andy, to be honest. And I think it's really a question that folks who are thinking about tap-agg, who are thinking about packet brokering, which way to go. I think there's also a kind of a use case kind of example there
Hmm.
too. I think I use this in a lot of our talks, to be honest, but that that is really critical that when you're mapping out what you're trying to solve for,
Yeah.
that you use the device that makes most sense. If you're looking to deploy hundreds of ports, hundreds and hundreds of ports through different, maybe a slightly complicated architecture kind of network, you need to make sure that, or if you're looking not necessarily scale, but in terms of complexity, if you're doing a financial services kind of rollout or you're doing a kind of more typical, it's the same value, obviously, but I'm saying in terms of typical for a enterprise system,
Yeah.
maybe you need to think about things differently. Maybe you need to put something as intelligent as a packet broker right at the edge of the network
Yeah.
for particular smart processing,
Yeah, I mean,
and that could
cybersecurity
be
might be an example where you'd actually want that packet broker right at the output or the input to your router. Maybe you wouldn't use a tap-agg there unless you just forwarded everything from that port, those ports.
Yeah, correct. So the point is, there's probably a little bit more to kind of scratch away at there, like a chicken, so to speak,
Yeah,
scratching away. But there's the spirit being, it's really important to think through what you're trying to do. Don't just go to the kind of a packet device, shall we say. I won't use tap-agg or a packet broker. Don't just look for the one that costs $5 and
yeah,
say, hey, that's good enough for me. Whether it's a tap-agg, whether it's a packet broker, doesn't really matter.
hmm,
You've really got to analyze the use case and do you understand what you're really trying to solve for? If not, I would take an extra few days, work out that question,
Yeah.
and then go around and shake the trees of all of those vendors out there to be able to see which is the best solution for your infrastructure.
Yeah, no, I think that's a good point. Okay, great. I think we've run out of time here, but no, I think that was a really good conversation. It really helps people to understand kind of where they should or shouldn't be using, the different classes of products. And we're going to go in a future call. We're going to go into kind of the packet broker architectures that are out there and why one is better than the other. And that's for a future discussion. But no, I think that's a good thing. I'd like to thank everybody for watching. Thank Ian again for his time. But as always, this has been Andy and Ian Talk Networking. I am Andy.
And I'm Ian.
Thank you very much.